Bismillah ar-Rahman ar-Rahim. In the name of God, the most gracious, the most merciful. Welcome to Lady Khadija radiallahu anha online college live lesson A-level maths. Today we are looking at a new topic within the trigonometric equation chapter, and this is an advanced technique and it's very useful. Comes up a lot, especially in the big mark exam questions. And it's called the R sine x plus alpha. Let's take a look at what it's all about. Let's suppose we had to solve an equation, something like 3 sine x plus 4 cos x equals 5, or let's say equals 1. Uh, what we'd look at is we'd see that there's a sine and there's a cos in the same equation, and we'd have a problem because there's no easy way to turn them both into sine or turn them both into cos. The only way we could normally get away with solving those kind of equations is if we had sine and cos on different sides of the equation, because then you could have sine, you could take the cos across to the other side, and sine over cos can be simplified to tan. So that's a good way of solving it, but that only works if the sine and the cos are in a position on different sides of the equation so that you can take the cos from one side and put it as a divide on the other. Here we don't have that luxury. We've got 3 sine x plus 4 cos x, and they're on the same side of the equation. Just to lead you into the topic, we're not going to worry about the equation part of it, but we're just going to take a closer look at how can we take something like this and simplify it so that it can eventually be solved. And the answer is this R sine x plus alpha form. So what this is saying is that you can simplify anything that looks like the above, looks like the first line, as in it's got a sine x plus a cos x, into something which is just sine only. It doesn't have any cos anymore. What it does have is that you'll have not just x, but x plus something. This is called alpha. It'll just be a number. But that's okay because once you inverse sine that, you can then take off the alpha from your answer. So that's not the problem. Problem was originally having sine and cos in the same equation. So how do we do this? How do we get it into the simpler form where we've just got sine on its own? So we start with just taking a guess that it is of the form r sine x plus alpha. And we say, look, if it did have this form, then we could expand the sign, not expand, but rewrite the sign, because the work we've done earlier on in the chapter, we know that sine a plus b can be split. So if you remember the original formula, it's a plus b, sine a plus b is equal to sine a cos b plus sine b cos a. So you know you've done that double angle formula. So we can apply that here, and if I just put brackets around this, so then just this bracket part, we'd have r on the outside, and then just rewriting that square bracket part with the formula we've learned, it would be sine x cos alpha plus, you should get to a point now where you're doing it from memory, so I haven't put that formula there, but you can remember the sine one's easy to remember. It's really just a repeat, sine x cos alpha, but when it repeats it just switches the angles, so it's sine alpha now cos x. So that's a different way of writing the sine bracket x plus alpha. And now what we can do is say Well, let's actually expand out the r now, so we can multiply the r. We've got two terms on the inside, so we can multiply the r by both terms. So you'd have r sine x cos alpha plus r sine alpha cos x, and I'll just put the alphas in a second. And you're probably thinking, well, we were supposed to make the original equation simpler, but we've done something that's quite complicated. But it's not really, because now what we can say is we can compare the original to what we've got here. And what we're trying to do is figure out what r and alpha is. So we're just going to do a direct comparison. We're going to say, look, this bit has got sine x in it. You can see the sine x here. So let's box the sine x. And then that same sine x appears here in our expanded version. So that means whatever's left, in this case, the 3 has to be equal to whatever's left here, which is the r together with the cos alpha. So let me just do that neatly. The sine x matches this sine x, so that means the r times the cos alpha, that has to match the 3. So let's write that separately. We can say, based on that first term, if the sine x matches, and we're saying that this whole thing is equal to each other, then the 3 from the top has to match the r cos alpha. And that'll help us figure out what r and alpha are in a second. So then, if that worked for the first term, let's take a look at the second term now. Let's use a different color. And we're going to say, look, the cos x matches perfectly here. So that means everything else must be a match as well. So here, if I use purple, then the 4 that's left over has to be matching the leftover bit here. So now I can set up that as an equation, and I can say the 4 has to be equal to sine alpha, r sine alpha. Let's put these two equations next to each other, and then let's use a familiar trick, which is when I've got a sine and a cos. I know that sine divided by cos will make tan, so let me divide the top equation by the bottom equation. So on the left-hand side, I get 4 divided by 3. I can just leave that as a fraction. On the right-hand side, the r, whatever's in the same on the top and the bottom, which is the r, cancels. So you're just left with sine alpha over cos alpha, which makes tan alpha. And then if you inverse tan 4/3, you'll figure out what alpha is. So let's grab a calculator. You can do it as well. Just type in 4/3 on your calculator or inverse tan that, whichever. On your calculator, most likely you press inverse tan and then 4/3. On this one, it's a little bit different, but here you go. It's 53.13. So I can write that alpha is equal to 53.13. And now to get r, we're going to take advantage of Pythagoras. And all we have to do is 3 squared plus 4 squared, and then square root that. There is a long way to do it, which is, now you've figured out what alpha is, 53.13, you could put that back into any of those two equations to figure out what alpha is. So it's a bit of a long way, so the quicker way is just to do square root of 3 squared plus 4 squared, the two numbers that you had in the beginning of the equation. So that becomes 9 plus 16 is 25, square root that becomes 5. So that means that r is equal to 5. Let's just do it the other way just to check. We know that alpha is 53.13. So we could say that, let me just make a bit of room. So the other ways to do it was be to take one of the equations we had before, and since we know what sine alpha is, I can rearrange this. So I've got just r on its own. I'm going to have to take the crossing out off. So if I just take sine alpha onto the other side, then r would be equal to 4 over sine alpha. Let's see if that gives me 5. So I'm just going to grab my calculator. 53.13 wasn't exact, so I might not get exactly 5, but I should get close enough. So if that's sine of alpha, and then do 4 divided by that, and that's very, very close to 5. So that's another way of getting it. But normally the Pythagoras method is pretty good because you don't have to rely on alpha. You can just take it straight from the question. 3 squared plus 4 squared, and then square root that. So I figured out what r is, I figured out what alpha is. How does that help me with the original question, which was how do I get something like this simplified? So it does simplify, and now I know what it simplifies to. So if I just take that to a new screen, then what I'm saying is that 3 sine x plus 4 cos x, that's an equation I don't really want to try to solve. It's got sine is different to cos, cos is different to sine. But I can put it into this format here, where I've not got cos anymore, I've just got sine. What value am I going to use for r? I'm going to use the value that I just calculated on the other side, which is 5. So I'm going to use 5 for r. And what value am I going to use for alpha? Again, I've already calculated that on the other side, on the other screen, which is 53.13. So that means if I substitute them in, I can say that this whole equation of 3 sine x plus 4 cos x, I can rewrite that in the form 5 times sine x plus 53.13. And that is a much, much easier equation to work with, or is a much easier expression to work with when I'm solving an equation. Okay, let's just go through a couple of the steps that helped us figure out what R was and what alpha was. So the key steps were, first you have to know what format you're putting the equation in. So what's the simpler format of the equation? That will normally be given to you in an exam. And then once you know it, you can then just rewrite using the double angle formula. So sine A plus B becomes sine A cos B plus sine B cos A. Just use that. Then from there, you want to do a comparison of each bit. So after you've expanded out the R, you just want to compare one bit with the other. So look at the bit that had sine x in the equation. That matches this bit here, which is sine x. So the number 3 must match everything else. That's your first equation, 3 equals cos r cos alpha. Now take your attention to the other bit. So this bit on the right-hand side, the cos x matches, so then the 4 must be equal to r sine alpha. So it's that matching that really is helpful. Then put one equation underneath the other, divide, the sine over cos will turn into tan, and then you can inverse tan that to get what alpha is. Once you've got alpha, you can figure out what r is just from the first two numbers. Use Pythagoras, 3 squared plus 4 squared, square root that, and that'll give you 5, and that'll tell you what r is. Once you know what r is, and once you know what alpha is, then it's just plugging it in to the simpler form of the expression, and then that's what you're going to work with. Okay, join me again for more on trig equations. Assalamu alaikum wa rahmatullahi wa barakatuh.